להתחיל? Okay, so good afternoon, everyone. I'm Michal Shmueli Scheuer, and I work for the language and retrieval group at at IBM Research AI, and today I'll present our work on IBM Science Summarizer, find relevant papers, and stay up to date with AI in less time. This is a joint work with all those great collaborators, and it was presented at EMNLP 2019. Okay, so we as researchers, we need to read a lot of papers. This is part of our daily work. And as part of it, we need to spend a lot of time. There are many papers and they are quite long. And the main idea behind the IBM Science Summarizer is to provide a tool that is able to help researchers to explore and to understand scientific papers, and it should take less time. So we do it by summarization. So if you look on what tools exist today for the scientific community, probably you're familiar with Google Search, Scholar, and Microsoft Academic. Those are mainly for search. There are some other tools like Ground AI, some subreddits, and the Archive Sanity pre-server. Those are tools that are mainly used for monitoring and some also for discussion. On the other hand, if you look on what tool exists today for summarization, there are quite a few, as you can see. However, their focus is a little bit different from ours, as we'll see now. So for those who are not familiar with how research paper or scientific paper looks like, on the right side, left side, this is the first page of our paper. So you can see it, and this is only the first, so we have the title, authors, we have abstract, section of introduction, subsection of use cases, links, references, tables, and so on. And usually such papers are around 8 pages. So this is a very long and complex document. On the other side, this is the type of document that usually the tools that I mentioned earlier can work good on. So those are kind of short text, or at least shorter text and much less complex. Usually the tools are trained on news data, like you see here. So they are quite short, and the language is a little bit different. Okay, so for us, in my group, it was quite obvious that we would like to have such a tool. However, in order to make our claims more systematically, we did some interviews in which we approached 6 potential users of such system, including a PhD student, 2 young researchers, 2 senior researchers, and some research strategists. And we asked them several questions, including a description of when they access scientific papers, how often they do this, how they explore the content, and what are the main pain points in current tools. So on the left side, you see the list of the topics and use cases that came out from the interviews, and they are sorted by their commonality. So the first one was the most popular one. First one was keeping updated on current work. Then we see people, they need to prepare research grants, they need to prepare related work if they are going to submit their own paper. They want to look for whether their idea is new new or not, if they want to submit, for example, a patent, or just in general, they want to study new domain or algorithm. So while the first one is actually on a weekly basis, or maybe I can also say it's on a daily basis now with the load of the papers, the other 4, they are, we can say more or less around few times a year. So the first use case is quite more common and also very often. And this is the use case that we decided to focus on in our system. In addition, we asked them also how do they do the search, and how they decide whether they are going to open the document, usually a PDF, and read the paper. And also here we see a lot of commonality between the way people are doing this process, and you can see that so they start with search by some keywords or what we call entities, maybe a name of a data set that they are interested, some benchmark, and so on. Sometimes if they know the title, they can type in the title as well. And here are some examples. So they can look for state-of-the-art results for Squad. Squad is the name of a data set. Or using BERT in abstractive summarization. Abstractive summarization is a task. And then once they have the list of links, they first read the title. Based on the title, they decide whether they think it's relevant or not. If they think it's relevant, then they continue to the abstract. Just to show, the abstract is up there up top there. It's usually around 100 words. So it's very short. And the main problem that they refer to is that sometimes it's too short and not informative enough in order for them to decide whether they actually need to read the paper or not, and therefore they need to open the PDF and read throughout the paper. Okay, so having all in mind, we designed and implemented the IBM Science Summarizer, where our approach was to summarize the content per section, and I will explain a little bit again later about what it means by section. In our system, we have more than 300,000 paper that we get from arXiv, from the ACL anthology, NeurIPS, and so on. The system take input entities, also some user interaction. In general, I'll show you a demo later, but the interaction is via a natural language query, and also you can filter and use different entities like task, dataset, if you know the source or the venue here, and so on. Okay, so how it works? We have first a pipeline of ingestion in which we acquire the PDF, in our case, the papers. First, they go into some extraction phase. We use the Science Parse, which is a tool from Allen AI, in order to extract the content of, so the text of the paper, figures, table, title, abstract, author names, and so on. And then we enrich the data. We are adding, extracting task, data sets, and metrics. And finally, when we have the enhanced content, we push everything into an index of Elasticsearch. On the other side, you see what happens during runtime. So there is a user query. First, we're doing some analysis and enrichment for the query. For example, we are doing query expansion in order to get better results. Then we run the query against the index. We get a set of documents that are relevant to the query, and based on the entities and the query, we get the summaries. Okay, so I mentioned that we are extracting entities. So if you recall, when we did the interviews, people said that often they search by entities. So I mentioned a task, maybe a data set, and in general we find it very important, at least for the computer science domain, which is the focus in our system. And hence we extracting tasks. Example can be question answering, post tagging, sentiment analysis. We extract entities of data sets and metrics. Metrics is usually the way that we evaluate machine learning algorithms and other algorithms, including precision, recall, F1, and so on. So the way that we treat this, we actually combined here two techniques. We are looking on dictionary-based. Dictionary-based is based on dictionaries of the same task, data set, and metrics that are coming from the website paper with codes. And those are manually curated. So you can understand that there are not a lot of issues, but there might be lots of issues. You need to update them manually all the time. So we're also taking an approach of learning in which, in collaboration with our colleague from IBM Dublin, we implemented what we call a textual entailment problem, in which we treat the content, the text as the content, and the triplet of task, data set, and metric as the hypothesis. And you can see that this module was trained on around 300 papers and tested on 160, and you can see the quality of the detection. So in total, after we combine these two approaches, we get around 870 tasks, 350 data sets, and 62 matrices. Okay, so now we get to the core of the system, which is the summarization. And the goal, again, is to generate a concise and informative section-based summary. So why it's a section-based? Often when you read a paper, or even when you write it, different sections, they have different goals. And in addition to the goals, also the language in the section, between sections in the same paper can vary a lot. So in order to be able to give enough attention of the algorithm to each one of the sections, we decided to do the summarization per section, and at the end, to actually concatenate all the sections into one long summary. And this is our approach. And the way that we do it, we're using an unsupervised extractive query-focused summarization algorithm. It is based on a previous system that we developed, which called Summit. So let me just explain a little bit. So unsupervised. Again, in the world of summarization, main issue is annotated data or ground truth data. For scientific paper, for example, there is no ground truth data of summaries. Also, we see this problem when we go to our customers. It's not the data that someone have ready, and it's very expensive actually to generate summaries. And that's why we took an approach of unsupervised. Then extractive. So summarization has two fashions, one called extractive and the other abstractive. In extractive, you basically have some content and you extract sentences as they appear in the original content. The other approach is an abstractive approach. In abstractive, you create new content based on the original data. Nowadays, we see, so most of the systems are doing extractive. But nowadays, with all the deep learning, we see some shifting towards the abstractive. Again, the quality is not as good as abstractive, but there is some progress as well. Okay, so what we have a document, which was an answer to the query. And then the first step is to segment it into sections. And then each section, we segment it further to sentences. Each one of the sentences in the section is actually a candidate to be part of the summary. So those are the inputs there. We have the user query as another input, and we also define something that we call objectives pool. And basically, those are objectives that the user can define what should be their target optimizations. And I'll show example in a few slides. All those inputs are getting to the core of the system, which is cross-entropy optimization. And the output is the selected sentences, which are our summary. So just a few words about cross-entropy methods. So this is a general Monte Carlo approach. And it's an iterative process in which we start there on the purple box with the random sample generator. So just assume that we have some text units. At the first step, all the text units have the same probability to be chosen. So it's uniform. And then we are doing some sampling, and each one of the sampling, we are evaluated with the objecting function, and each one of the samples gets some score. Then we have the elite sample. Those are the samples that got the higher scores based on the optimization objectives that we define. And now, if the elite samples are good enough, so they are above some threshold, then we said, okay, we are done. However, if they are not good enough, then we are going back to the purple box. But now, we want to do is to update the distribution, because we already have some elite samples. So we know that there are some text units that are better than the others. So now, instead of having a uniform distribution, we give a higher value of the probability is higher for those that were already shown as good, and thus we keep doing this iteration until we converge to some good result. Okay, so how it applied in our use case? So in our use case, the text units are sentences. Okay, so you can assume we have a section, let's say, with 100 sentences. At the beginning, each one has a probability of 0.01 to be chosen. Then let's assume that I want to create a summary of 10 sentences. So I randomly generate, 10,000 summaries with a uniform distribution. Then I evaluate them with the qualities and get a score. And we define the elite sample to be the top percentile, so 1% of the summaries. And if it's not good enough, we are updating. So now in the elite samples, we have summaries that perform better than the others. So it means that some of the sentences in them will get a higher probability to be chosen again and again until we'll converge into the solution. Okay, so I mentioned those quality evaluation. In our case, for simplicity, we are doing some linear combination of different qualities. Just a few examples. So for example, the query saliency. The first one is looking on different similarities measures between the language model of the query and the language model of the summary. The text coverage, for example, is looking on how well the summary covered the document. Okay, there is no query here, so how well the summary that we generate covered a document. Diversity, so in general we want the sentences that we choose to create a diverse summary. Also for the length, we tend to prefer longer sentences. Longer sentences, usually they are more coherent and more informative, and thus we prefer longer sentences. And so on and so forth, and based on your task, you can define any optimization goal qualities as we did. Okay, so as I mentioned, there is no ground truth data to evaluate our summaries. And in order to do something, at least to show some quality, we went and did some human evaluation. We approached 12 NLP researchers, which each one of them was the first author of a paper, of his own paper, and we gave them 2 summaries. First summary is what we call the section-based summary, which is the summary that I described that our system generates. And the other one is section agnostic. So what is the idea? Let's assume that in the section base we have 6 sections, and we allow 10 sentences per section. So in total, we'll have 60 sentences as the summary of the paper. So we take the same budget of 60 sentences and we give it to the algorithm, but now we just give him the whole document. So we no longer tell the algorithm to do it on a section-based basis. So this is the 2 summaries that we generated. In total, we have 48 summaries, and we ask 3 questions for the authors. The first one is for each sentence in the summary, whether you consider it as a good sentence to be in a summary that you would generate. And this is more what we call a precision-oriented measure. Then we ask them for each section how well this section was covered by the summaries. And this is more a recall-oriented measure. And finally, in general, how did you like the summary? And it varies between 1 to 5. You can see some results here. So for all tasks, the section-based outperformed the section agnostic. You can see, for example, I don't know, for task 2, the score was 3.32, which is above good, so it's between good to very good. And 68% of the summaries were actually better than the section agnostic. Okay, so I have 2 minutes. I'll try to show you a demo. So the system is actually, there is a beta version that that was just started at the new RIPS, so it was maybe 2 months ago. For now, we have around 60 queries per day and 150 interactions, so it's a very low but stable load. So you are welcome actually to try it by yourself and to send us feedback. It's still in the phase that we are learning. So let me try. Okay, so okay, I'll try to. Okay, I'll choose the first one. So, okay. Okay, so what we see here, I wrote abstractive summarization, and then what we get, let's scroll down. Okay, I'm sorry, I forgot how to scroll down in Lenovo. Okay, so you see, sorry. So each entry is a paper, and if there is some interesting figure or table, we show it. In addition, okay, אני רק אכנס לתוך. Okay, when we click on Okay, when you click on a paper, then what we see, okay, so we see here, for example, okay, so the abstract, we are not doing any summarization. This abstract is already very concise. There is nothing that we can do to summarize it. But other section, you can see that they have this AI-powered summary. So we are doing some algorithm there. Then for related work, you can either click, to skip 2 sections or just read the whole summary as is. Okay, let me try it just with him. You can also, for example, if you are interested in papers from new RIPs, you can go and do the selection from here, maybe a data set, ImageNet maybe. And after you filtered and search for what you are after, then again you can either from here read the summary or go open it and read the summary of the whole paper. Okay. שאלות? כן.
Just have why you say that longer sentences are more coherent? They provide all the information, I understand. What is the coherence part?
So actually it's a combination of the information that they provide and usually when they are very short and concise, it's very difficult to understand where they came from. They don't have encode enough information in them. So maybe coherent is not exact measure, but informative. Maybe this is the way that we define it, yeah.
And in the summarization, the abstract summarization, just my eye, it says there is a tendency of the system to have long sentences in the abstract, in the creation of text, have sentences, long sentences.
In the abstract?
Yeah, no, not in the abstract.
Oh. Yeah. So we tend to prefer, yes. So this is one of the objectives that we decide. We saw it as important objective to have to prefer longer sentences rather than shorter ones. And this is one of the objectives that we define. So in the process of the optimization, we tend to prefer those longer sentences. Okay, other questions? Okay, thank you.